In Lesson 12.3, we're going to take a look at sample spaces. So first, we're going to talk a little bit about the counting principle. The counting principle is just sort of a little bit of a shortcut that we use. So a lot of times in standardized tests, like the ERB and things, they ask you how many different outfits can you make. So if you have 5 sizes of shirts and 7 colors, so how many different types of combinations can you make? So if you use the counting principle, if there's m ways of doing one thing and n ways of doing another, all you have to do is multiply those two numbers to figure out how many total outfits you have to choose from. So if you have 5 sizes of shirts and 7 colors to choose from, there are 35 different shirts that you could pick. And so that's the counting principle. It's a nice little shortcut. And a sample space is, oops, fix that, all the possible outcomes for an event. Okay, so I'll say listed out because you write them all out in the sample space. So the counting principle lets you know how many there are, but the sample space is all of them listed out. Oops, that's not what I wanted to hit. Okay, so let's find a sample space. So a sample space is dividing into 5 equal sections, A through E. So I have A, B, C, D, and E. Okay? Now I'm spinning the spinner twice. So I could spin an A and an A. I could spin an A, then a B. I could spin an A, then a C, A, then a D, A, then E. Okay? So you're going to want to list these all out using a set system here so that you know you don't miss anybody. Now everybody that starts with a B, I could do B, then A, B, then B, B, then C, B, D, B, E. So this is my sample space. I'm just going to keep doing this and list them all out. C, E, D, A, and I'm doing that because that's what they said. It says write all the outcomes as ordered pairs. You do not always have to do this. It's just because this is what the question asked me to do, so that's why we're doing it. E, A, E, B, E, C, E, D, and finally E, E. Now, using the counting principle, for the first spin, there were 5 letters that I could have hit. For the second spin, there were also 5 letters that I could have landed on. So to figure out the total, 5 times 5 is 25 possible outcomes. And you can see that that's what we got here. We got 25 outcomes in our little table here. So now we're going to use this to find the probability of spinning at least one D, which means, whoops, can be 2 Ds. So at least means 1 or more. So let's highlight. Every time I see a D, 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 all of these have Ds and a D. So how many outcomes had at least one D? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 outcomes with at least one D. And there are 25 possible outcomes, so the probability of getting one D is what I want out of the total. So 9 over 25. And I can't reduce that, so we're done. Okay, so now you're going to do the quick check. And what you need to do is give the samples, whoops. No, let's fix that. Okay, So give the sample space for tossing 2 coins. Okay, so your only options are a heads and a tail. Whoops, not another heads. Heads and a tails. So you want to list them. And there should be 4, because for the first toss, you could have 2 sides of the coin. So for the second toss, you're also going to have 2, and 2 times 2 is, there's 4 possible. So now list them all out, just like we did the ordered pairs. Okay, what order could you get the flips in? And then find the probability of getting 2 heads. So probability of 2 heads is what? Give me a fraction. Okay. When you're ready, move on to the next part. All right, now we're going to use a tree diagram. Let's bring this over here. Okay, so suppose you can go west or northwest. Okay, so that's 2 options. By train, bus, or car, which is 3 options. So by the counting principle, I know that I should have 6 possible outcomes. Draw a tree diagram to show the sample space for your journey. So I could start with the train and go west. I could start with the train and go northwest. I could do bus to west, or I could take the bus and go northwest. I could take a car and go west, or I could take a car and go northwest. So you can see I got 1, 2, 3, 4, 5, 6 possible outcomes, which is what I got by using the counting principle. So the counting principle is great. All right, so what's the probability of randomly selecting, of a random selection that results in a bus trip west? So bus west, there was 1 outcome for taking a bus and going west out of 6 possible outcomes. So the probability then is 1 out of 6. Okay, so now we're going to try the last example here. All right, and this is usually what happens. This is how it looks on standardized tests. So this is really important here. Using the counting principle. How many kinds of coin purses are available if the purses come in small or large and in the colors red, blue, yellow, and black? So you can see over here, you have 2 options for the size and 4 options for the colors. So how many different options, or how many different purses can you find? Well, 2 sizes, 4 colors, counting principle, you just multiply them. So there are 8 different kinds of coin purses available. Okay, so now in the quick checks, you're going to do a tree diagram for the first one. And you're adding an extra mode of transportation. So you're just going to draw a tree diagram just for the, what are we adding? An airplane. So you're going to do an airplane and then draw the branches coming off of it and see what happens. Then you're going to use that to find the probability of selecting an airplane at random for your journey. So that means all options that include the airplane. Okay, out of the total. And in quick check 3, a manager at the deli counter decides to add chicken to the list of meats. How many different sandwiches are available now? So you're going to add chicken in here. Sorry, you can't really see that. You're going to add chicken. And now figure out how many different sandwiches. So just use the counting principle. Okay, and we'll check your work in class.